Hello viewers, welcome to another video on solved examples related to plasticity characteristics of the soil. For today's video, I have taken an example from Mumbai University exam which was asked in December 2017. So the question is, the plastic limit of a soil is given as 25% and its plasticity index is 8%. When the soil is dried, so from its state at plastic limit, the volume changes 25% of its volume at the plastic limit, and the corresponding change in the volume from liquid limit to dry state is 34% of its volume at the liquid limit. So with this given data, I have to find out the value of shrinkage limit and the shrinkage ratio. Now first, before step for this question, so finding out the solution for this question is, I have to find out the value of liquid limit. So by definition of plasticity index, we know plasticity index is the difference between liquid limit and plastic limit. I'll substitute the values of plasticity index in liquid limit, and I'll find the value of the liquid limit, that is 33%, or we can say 0.33. Let us say that V dash be the volume change of the soil, VL be the volume of soil at the liquid limit, and VP the volume of the soil at the plastic limit. With the given data, the volume change at it is VL minus 0.34 into VL. So when the soil volume was changed at the dry state, it was 34% less of what was the volume at the liquid limit. So VL was the volume of soil at the liquid limit, and dry volume is minus 0.34 into VL from the original value of the soil at liquid limit. Similarly, V dash is equals to VP minus 0.25 into VP, because the volume change of the soil was 25% less as compared to the volume of the soil at the plastic limit. So we get this equation 1 and 2. I'll equate both this equation. So it becomes 0.66 into VL into 0.75 into VP. So I'll write VP in terms of VL, and VP is equals to 0.88 into VL. On side, I'll draw an Etterbox chart. So I know now the liquid limit value is 33%. The value of the plastic limit is 25%. Shrinkage limit is not known to us. The decrease in the volume from the liquid state to the plastic state is 12%, and that from the liquid state to dry state is 34%. So VP and VD, that is the volume of the dry soil, is represented and shown in this figure. Now the next step is, I'll use the property of similar triangle, and in triangle CFD and BED, I can say B upon DE is equals to FC upon FD. So therefore, by similar angle in this particular figure, I can say BE upon DE is equals to, BE upon DE is equals to CF upon FD. So I'll write here BE upon ED is equals to CF upon FD. Now BE, if we carefully look at this figure, it is the difference between the shrinkage limit and the liquid limit. So we have to find out that, so we'll keep as it is. The value of DE can be taken as 34% or 0.34. So I'll write BE divided by 0.34 equals to, Now value of FC, if we see, that is the difference between the liquid limit and plastic limit, that is 8%, that is given to us. So I'll write here 0.08, and the value of FD is 12%, or we can say 0.12. So we'll substitute that also. So if we solve, we'll get the value of BES. So we have to solve it. That is 0.08 divided by 0.12 multiplied by 0.34. So it comes out as 0.227. 0.227. So this line BE represents the difference between the liquid limit and the shrinkage limit. So therefore I'll say BE is equals to difference between liquid limit and the shrinkage limit. So I'll say 0.227 will be equal to 0.33 minus shrinkage limit. So therefore the shrinkage limit value will be then available with us. So therefore it will be 0.33 minus 0.227. It will be 0.103, or we can say 10.3%. Now the next part is to find out the shrinkage ratio. So shrinkage ratio SR can be found out using the expression VL minus VP upon VD into WL minus WP. Now the value of the VL is to be kept as it is. VL, we know it is 0.88 VL. VD is 0.66 VL, and here the water content values are already known to us, that is 0.33 and 0.25. So therefore we'll solve it further. So here it will be 0.12 into VL upon 0.66 into VL. So this gets cancelled out, and in bracket it will be 0.08. So therefore if we solve it, that is 0.12 divided by 0.66 into 0.08, shrinkage ratio value comes out as 2.27. So the values of the shrinkage limit and the shrinkage ratio is computed, and that's all from this video. If you have liked the video, hit the like button, share it with your friends, and subscribe to our YouTube channel. Thank you.